Equipment Lesson 16 covers the exposure index and dose creep, two digital imaging concepts that directly govern patient dose in every department running digital radiography. In the film era, overexposure was immediately visible. In digital imaging, it is not. That invisibility is what makes the exposure index and the deviation index so important, and what makes dose creep so dangerous. 11 minutes. The exposure index, or EI, is a number generated automatically by the digital detector after every exposure. It represents the amount of radiation that reached the detector. A higher EI means more radiation. For things to understand about the EI. First, it is manufacturer-specific. The same patient exposure produces completely different EI numbers on a Fuji system versus a Carestream system versus a Siemens system. The numbers cannot be compared across manufacturers. Second, it is not a measure of image quality. A high EI does not mean a good image. It only means the detector received more radiation. Third, when EI is too high, the patient received more radiation than needed. The image still looks diagnostic because digital systems compensate electronically. There is no visible indication of overexposure on the monitor. And fourth, when EI is too low, the detector received insufficient photons. Quantum noise becomes visible. The image looks grainy and mottled, and maybe non-diagnostic. Every facility sets a target EI for each exam type during acceptance testing with a medical physicist. Know your system's target values. Review the EI after every exposure. Make it a non-negotiable step in your workflow. The Deviation Index, D1, was standardized across all manufacturers by the International Electrotechnical Commission in IEC 60 2494-1. Unlike the EI, the D1 is directly comparable regardless of which system you use. The D1 scale runs from severely negative on the left to severely positive on the right. 0 is optimal. Always. D1 formula. D1 equals 10 times the log base 10 of EI divided by target EI. A change of plus or minus 1 D1 unit represents approximately a 25% change in detector dose. D1 between -1 and +1. Optimal range. D1 beyond plus or -1. Investigate. Identify whether this is a random variation or a systematic technique problem. D1 beyond plus or -3. Mandatory corrective action required. Document, investigate root cause, and correct technique before repeating exposures of the same type. Both directions are problems. D1 negative below target. Quantum noise degrades the image. D1 positive above target. Patient received unnecessary dose. Neither is acceptable under ALARA. This chart shows the same equivalent patient exposure producing wildly different EI numbers across manufacturer systems. Fuji S-value, approximately 200. Carestream EI, approximately 1,000. Siemens EI, approximately 300. Philips LGM, approximately 3.4. Same dose, completely different numbers. Two things to lock in about manufacturer EI systems. First, never compare EI numbers between different manufacturer systems. They are not equivalent. Comparing a Fuji S-value of 200 to a Carestream EI of 200 is meaningless. They represent completely different dose levels. Second, and this is a registry favorite fact, the Fuji S-value and Konica S-value are inversely proportional to dose. Higher S-value means less radiation reached the detector. A Fuji S-value of 200 is the typical target. An S-value of 400 means the detector received half the target dose. The image is underexposed. An S-value of 100 means the detector received double the target dose. The image is overexposed. The inverse relationship of Fuji S-values is directly tested on the ARRT. The line chart on this slide shows what dose creep looks like when you graph average D1 values by month for a single exam type. January, D1 of 0.1, essentially optimal. By December, D1 of 2.1, more than double the required detector dose for every patient imaged in those later months. The images still look acceptable at the workstation throughout. Dose creep is the gradual, unnoticed rise in exposure levels in digital radiography departments. From mechanisms drive it. Digital compensation. Digital systems process the raw image electronically. Overexposure looks diagnostic. No immediate visual feedback, unlike film. Technique drift. Technologists gradually increase technique over time, unconsciously, adding a little extra moss just to make sure. Multiplied across hundreds of exams, the cumulative dose impact is significant. Unmonitored AEC. AEC malfunction or incorrect chamber selection causes systematic overexposure that goes completely undetected without D1 monitoring. And no D1 auditing. Without regular department-wide D1 trend analysis, dose creep is invisible. Individual exam D1 values look borderline acceptable, but the trend reveals the systematic problem. 5 strategies for preventing and detecting dose creep. 1. Monitor D1 on every single exposure, not just when the image looks wrong. A visually acceptable image with D1 of plus 2.5 is a real patient safety problem. 2. Regular department-wide D1 audits. Pull D1 data by exam type, body part, and technologist monthly. One exam at D1 plus 1.5 may be acceptable. 10 consecutive exams of the same view, averaging D1 plus 1.8 indicates a systematic overexposure requiring immediate technique review. 3. Investigate root cause, not just the image. When D1 is consistently elevated, check AC chamber selection, centering accuracy, technique chart values, and whether technique is being modified from the chart. Fix the cause, not just the number. For update technique charts and protocols annually with a medical physicist. Out-of-date charts are a leading source of systematic overexposure, especially in departments that have upgraded their equipment since the charts were written. And 5. Establish and enforce alert thresholds. D1 beyond plus or minus 1. Document and monitor. D1 beyond plus or minus 2. Investigate. D1 beyond plus or minus 3. Mandatory corrective action before repeating the examination. The most dangerous misconception in digital radiography. Digital systems are forgiving. Technique doesn't matter as much as it used to. The truth is the opposite. Digital systems are less forgiving of overexposure precisely because overexposure is invisible. Film punished overexposure immediately. A dark, fogged image required an obvious repeat. Digital compensates electronically. The patient receives excess dose with no visible consequence at the console. A ALARA, as low as reasonably achievable, applies equally in digital imaging. In fact, the responsibility is more critical in digital because the visual feedback mechanism has been removed. ALARA practice in digital radiography. Use the minimum technique that achieves D1 near zero. Monitor D1, not just image appearance, after every exposure. Never increase technique, just to be safe, without clinical justification. Correct centering and AEC chamber selection are dose management tools. Collimate aggressively on every exam. Report and investigate any D1 trend that deviates from target. A good image at the wrong D1 is not an acceptable outcome. 3 exposure index and dose creep questions. The answer is C. Document the elevated D1, investigate the cause, and correct technique for future exposures. A D1 of plus 2.7 indicates the detector received approximately 3.5 times more radiation than needed. Repeating an already diagnostic image doubles the patient's dose without benefit, directly violating a ALARA. Adjusting the window width changes how the image is displayed. It does not change the dose or the underlying data. Document, investigate, and correct. That is the correct ALARA response. The answer is B. Dose creep from unmonitored technique drift. A D1 rise from plus 0.2 to plus 1.8 over 6 months, while images continue to appear acceptable, is the textbook definition of dose creep. Digital systems compensate electronically. The images look fine, while the cumulative dose to every patient in that period was approximately double the required level. Only systematic D1 trend monitoring reveals it. The answer is B, underexposed. The Fuji S-value is inversely proportional to dose. A higher S-value means less radiation reached the detector. S-value 400 with a target of 200 means half the target dose was delivered, underexposed. This is one of the most commonly tested manufacturer-specific EI facts on the ARRT. Know that Fuji runs opposite to most other systems. You covered what the exposure index measures, the deviation index scale and formula, manufacturer EI system differences, including the inverse Fuji S-value, dose creep with a trend chart, prevention strategies, and a ALARA in digital imaging. Monito do. Every exam, every time,